to solving this problem is to think about transforming the left side of the equation into something with only one trigonometric function in it. So I would try writing everything in terms of cosine and see what happens. So I replace cotangent squared with cosine squared over sine squared. But sine squared is 1 minus cosine squared. And then to get rid of this complex fraction, I multiply numerator and denominator of the, quote, big fraction by 1 minus cosine squared. And when I take this times this first fraction, the denominator and the numerator and this multiplier cancel out. So I get cosine squared minus cosine squared times the quantity 1 minus cosine squared. After I distribute this cosine squared, I can see I get cosine squared minus cosine squared plus cosine fourth. And then these guys cancel out. Let me go to red. And I've got 1 minus cosine squared over cosine squared. I can replace, now I see where we're headed. Sine squared is the same as 1 minus cosine squared, but sine over cosine is the same as tangent squared. So in effect, I've rewritten the equation as tangent squared theta equals 3. And that's the equation I want to solve. Well, I can take the square root of both sides. So the tangent of theta equals plus or minus the square root of 3. So theta equals the inverse tangent of plus square root of 3, or theta equals the inverse tangent of minus the square root of 3. Excuse me, but we're told to find solutions for theta that are in the first quadrant when we know that the tangent is not negative in the first quadrant, so we can reject this answer. We don't have to continue there. What angle in the first quadrant has a tangent of the square root of 3? Well, looks like a 30-60 right triangle to me, which means this is 60 degrees. So that's your answer right there. And of course, to convince yourself, you could put 60 degrees in for theta in the original problem and see if you get an answer of 3. I think you'll see that you do. Okay, there you go.